In this lecture, we will continue our discussion on corollaries of Cauchy-Goursat theorem. Corollary. This corollary is known as extension of Cauchy-Goursat theorem for multi-connected region. Extension of Cauchy-Goursat theorem. Cauchy-Goursat theorem. Goursat theorem for multi-connected region. For multiply connected region. Multiply connected region. First is the statement. Let D be a simply connected region. D be simply connected region. Simply connected region. Connected region. Bounded by the curve. Bounded by the curve. By the curves C1 and C2. C2 content in C1 and FZ is analytic in the region between the curves and continuous in C1, then integral C1 fz dz is equal to integral C2 fz dz, where C1 and C2 traverse in positive sense. That is in anti-clockwise direction. In the statement, it is given these are simply connected region bounded by the curve C1 and C2, where C2 is contained inside C1. Fz is analytic in the region between C1 and C2 and continuous in C1. Then integral over C1 and C2 are equal, where C1 and C2 are traversed in a positive direction, anti-clockwise direction to each other. Proof. First, draw this figure. This is our curve. Anti-clockwise direction. This is another curve. This is in traversing opposite to each other. E. If A is a point in this curve, this is our C1 curve. This is C1 and this curve is C2. Okay, this is the curve between them, region between them. This is A, this is B, this point is C, this point is D, and this is my point P. This is the point Q. This is the point R. If we make a cross cut, This is from cross cut is from A to B. Cross cut AP. According to the statement, it has given that the integral C1 fz dz integral over this curve C1 is equal to integral over this curve C2 fz dz. Fz is continuous in the angular regions between C1 and C2 and continuous at C1. So right, we connect the curve C1 and C2 with a narrow cross cut. This is the narrow cross cut. Okay, at point A in the curve C1 and at point B in the curve C2. Then starting from A, moving to B, then move to C, then move to D, then again move to A, then goes to P, then goes to Q, then goes to R, then again move along the curve here to the point P, then again come back to A. That is when starting and the terminal point coincide, then this will be a simply connected region. A, B, A, B, C, D, A, P, Q, R, P, A is simply connected region in which FZ is analytic. Okay, and in the boundary it is continuous. In the boundary FZ is continuous. FZ is continuous. Therefore, by Cauchy-Goursat theorem, answers satisfy all the condition of Cauchy-Goursat theorem. The region is a simply connected region. Here the region is simply connected region. Fz is analytic. Therefore, by Cauchy-Goursat theorem, integral over this region A, B, C, D, A, B, Q, R, P, A, Fz dz is 0. Integral over the simply connected region is 0. And from this diagram we can see that A B C D A is one curve. So write that integral over A B C D A Fz dz plus again integral along A to B. Integral along A to B is another curve Fz dz plus integral over PQRP. This is a simply connected, that is final initial and terminal point is coincide. So here I write P in the beginning and again at the end I will write PQRP. Here again I have written A, B, C, D, A, because this is simply connected regions. Okay, so this is connected region. I have written this one. Again, there will be another integral, that is BA. That is BA. I have reached up to this point. Up to this point, again I will return back to A. So this is BA. Fz this equal to 0. Here, this integral and this integral are opposite to each other. One is AP, other is BA. Okay, one in the first we will come from here, in the other it will be opposite. So one is the negative of other. So in the next step we will get this A B C D A F Z dz plus integral P Q R P F Z dz equal to 0, since integral AP F Z dz is equal to integral PA F Z dz. A B C D A F Z dz is equal to integral minus P Q R P F Z dz. Here A B C D A B C D A, here A B C D A is this curve, that is C1. So this is your C1, left hand side of this is C1. This is C1 curve. This is the integral over C1 curve. So write integral C1 Fz dz is equal to integral, this is minus PQRP. So PQRP PQRP, so minus, so opposite the orientation, so this will be C2. Here I'm moving from this, my curve is this direction, but I'm moving opposite direction, so this is minus, minus when the orientation is opposite to the orientation of the curve, that is PQRP. Our orientation of the curve is PRQP, but I'm moving from PQRP, so this is minus C2. So minus minus will be plus. C2 Fz dz. Hence the theorem. That is integral along the curve C1 is equal to integral along curve C2. Hence the theorem. Next, the generalization of this theorem. If the if C is closed curve, and C1 C2 dot are the closed curve which lies inside C, are the closed curves which lies inside C, and Fz is analytic in the region between this curve. Fz is analytic in the region between this curves and continuous on C and continuous on C, then we can generalize by using above theorem as integral over C fz dz is equal to integral of sum of the integral over the closed curve C1 fz dz plus C2 fz dz plus dot dot dot. That means if this is my closed curve C and there are curve, this is opposite orientation C1, there is another curve C2, then this happens. Integral over C is equal to integral over this C1 plus integral over C2 close. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.